I talked about odd numbers, and odd numbers had to end in an odd number, correct? That was how we did odds and evens. And then I asked you a question that had nothing to do with odds and evens, and you answered it in even and odd correctly, though, so that was good. And if it says a 4-digit number, then it can't start with a 0, right? Because then it would be a 3-digit number. Now, the last one didn't say anything about not being able to repeat, so we assume that we can repeat, right? So the only time you can't repeat digits or letters or whatever is if it says you cannot repeat, okay? Or if it says I only have this word, like pool, then I only have one P, 2 O's, and a noun, okay? So here it says, how many odd 4-digit numbers, so we're still doing odd 4-digit numbers, that didn't change, but here it says with no repetition. So I always make us box and hold, is what I call it. Like whenever it says you can't repeat, I box and hold numbers. So I still have to start with the restrictions first. So in the back here, I have 1, 3, 5, 7, and 9. Okay? Still have to start there. Still have to have an odd number on the back digit, right? That's how I know if it's odd or even. Yes? Okay. How many options is that? It's a 5, right? So I put a 5 here. Now, last time I went to the front and I put 1 to 9 right away. The difference between this one and the previous example is it says I can't repeat, correct? So what I need to do is I need to box and hold one of those numbers so that I can't repeat it. So make sure everyone's paying attention. So I'm going to box and hold the 9. I could have picked the 1, the 3, the 5, the 7, or the 9, right? I just need to pick one, box it. Now I pretend it's held. Now I picked the 9 so that I could go 1 to 8 because I'm lazy. If I picked the 5, I would have to go like 1, 2, 3, 4, 6, 7, 8, 9, right? I picked the 9 so then I can go 1 to 8. So how many options is that now? How many is 1 to 8? 8. Now I hold the 8. I put the 8, I hold the 8. Now I have 1 to 7. Now some people will tell me it's 7. But you have to watch yourself. In the back blank, I could use 1, 3, 5, 7, 9. In the front, I could use 1 to 9, but I used up 9, correct? Yeah.
Would it be 0 to 7?
Yes. You actually have to do 0 to 7. 0 hasn't been used up, but I couldn't use 0 back here. It would be even. I can't use a 0 in the front because I'm not allowed to, right? So I have to remember to bring the 0 back here. So it's actually 0 to 7, which is 8 options. Say I hold the 7. Then it would be 0 to 6, which is 6 options. That's 7. That's really funky 7. There you go. 7 options. What's 8 times 8 times 7 times 5? Since it's not hot enough in here, I'm also going to drink tea just to really increase the body temperature. I just realized how stupid this is under. What's 8 times 8 and 7 times 5? 2240?
Yep.
Thank you. Now, if this was a written response, I would say there are 2,240 different odd 4-digit numbers that do not repeat. Like I have to write my full sentence, right? Okay. We're going to skip number 4. We're going to go to example 5. So example 5 here says, the telephone numbers allocated to subscribers in a rural area consist of one of the following. So I have the digits 3, 4, 5. So they have to be 3, 4, 5, right? So I have 3 blanks. So I have the options 3, then 4, then 5. Remember on the bottom I list the options. On the top I list how many there are. Bottom, options. Top, how many? Number of options. Followed by any 3 further digits. Digit, digit, digit. So is there any restrictions on those digits? No. So what numbers could they be? What options do I have?
1 to 9.
Even more.
0 to 9.
0 to 9. Then I have the word or. Remember, and means multiply, or means add. Because and add are too similar, right? And add don't go together. So if I have the word or goes with addition. So if I have or, I'm going to do a plus sign. The moment I have more than one case option, cases will always be added together. So I have this case or I have this case, I take this case, I figure it out, multiply it, plus this case. So you always have plus signs between cases. The next option I have is the digit 2, followed by one of the digits 1 to 5, followed by any 3 further digits. So once again, we have 0 to 9. Make sure you have the multiplication dot in between all of your blanks. You have to have multiplication dots or it's just a number, right? You're just reading a number. Okay, so underneath I list all of my options, right? What the outcomes could be. Above the line, I list how many there are. So for this first blank, how many are there? 1. What about this one? And 1, 5 is 0 to 9, 10, 10, 10. What about this one? 1 to 5, 5, and 10, 10, 10. So the two numbers we are actually adding, 1 times 1 times 1 times 10 times 10 times 10 is 1,000, plus 1 times 5 times 10 times 10 times 10 is 5,000. So I get 6,000. When you're done, please put down your pencils and pens. I need you to pay attention and not be distracted. Okay. The next one, I have the word English. So, I know that this is being recorded and people can't see this, but I'll try and describe it. So I have an E tile. I have an N tile. 1G, 1L, 1I, 1S. Get rid of this calculus off the board. 1H. So do they have to tell me that I have no repeating letters if they tell me you have the word English? No, because you literally have the word English. It's like Scrabble tiles. It's like if they gave you, you had your Scrabble tiles laid in front of you, you have 1 E, 1 N, 1 G, 1 L, 1 I, 1 S, 1 H. So they don't actually have to say that I have no repeating letters. Because if they gave you the word pool, for example, you'd have 1 P, 1 O, 1 O, or 2 O's, and 1 L, correct? Because the word pool has 2 O's. That's how you get more than one, okay? So they're not going to tell you that you can't, they're not going to say you can't repeat, which they had to do in that other odd example. They're not going to say you can't repeat because they just say you have the word English. So there it is. So here it says, consider the number of distinguishable. Distinguishable just means you can tell them apart. So if I had the word pool, and then I swapped the O's and I had the word pool, you wouldn't be able to tell them apart. Those would be not distinguishable because it would still say the word pool, right? So we need 4-letter arrangements. So when we do words, we always do the fundamental counting principle. We do the blanks because every single blank can still only hold one word. Like every blank in the previous examples could hold 1 digit, correct? Same thing here. So it says here, consider the number of distinguishable 4-letter arrangements. Arrangements means the permutation because order matters. That can be formed with the word English, any letter in any position. So the first thing I'm going to do is I'm going to have 4 blanks. We agree? It's a 4-letter word. But in every blank, I can only have 1 letter, right? We know that. So in the first blank, how many tiles options do I have for that first blank? 7. Then I have to leave 1 behind, correct? Because I'm trying to spell a word, and I'm not allowed to keep... If you don't leave one of these letters behind, like if I don't put an E here and leave it behind, then I could use an E here. I'm never, ever... It's struggling because it's wanting to write right now. On my other board, it didn't do that. This board just rocks. It's my favorite. I wish I could have 2 of them. Okay, if I have to hold it here. This totally ruins what I like doing. I just take my shoe off. Okay, visualize an E stays there. Okay, there's an E there. Cool. Used it up. True? I'll write it below. There's the E. It's a piece of paper. You just can't see it because it's on the floor. Okay, cool. How many letters do I have left for the next one? 6. Say I leave an H there. We didn't even touch the board. It just did that. Cool. Okay, then how many do I have left? 5. Which one do I want to leave? An L. Cool, there it is. I'll pick those up later. What about this one? 4. Does it mean I left E, H, L and that there? No, it's just I'm leaving an option there so that it shows that I've used one up, right? Then I know I have less. So words will always be cannot repeat. You always have to leave a letter behind or you're never spelling out a word, right? If you said 7, 7, 7, 7, that means you took all the letters, you said, okay, I have 7 here. You don't leave one there. You get to the next blank, I have 7 here. You're never actually leaving a letter behind, you're never spelling a word, okay? So words are not repetition. So 7 times 6 times 5 times 4 is what? What do we get? Now I want to show you something else. If you start at a number and you go down by 1 per blank, you can actually use permutations. You can use the P, and I'll show you. So what number did we start off with? How many? 7. P. How many blanks did we use?
3.
Blanks. 4. We're going to type that into our calculator. Go to your calculator, every single one of you. So the first number is how many letter options you have. The second number is how many you choose. And you have to go down by 1 each time. So you're going to do this. You're going to go 7. And then you're going to press math. And then you're going to arrow to the left, or to the right more, to the PRB at the top, which is probability. And you're going to pick which number? The NPR one, which is that? 2. And then you're going to press number 4, enter. Do you see an answer? Yeah. What does it say? You can only do this, though, if you started a number and you can't repeat, like you go down by 1 each time. If I have like 7, 6, 5, and 8, or let's say 7, 6, 5, and 2, I can't do that, right? Like this one. Okay, 1, 2, 3, 4. Still 4-letter word, but it must, the first letter must be an E. How many E's does English have? It has 1, right? So, put my 1 E here, I have 1. I hold my E, box and hold. Whenever it's a word, you're boxing and holding, because you're using it up. Now, how many, that's the only restriction I have, and I have to go with restrictions first. How many options of letters do I now have for the second one? 6. And then I can leave anything behind. If you don't believe me, it's NGLISH is what I technically have left, right? Say I leave the H there now. How many do I have left for this one? 5. NGLIS. Hold the S. How many do I have for this one?
4.
Yeah, NGLI. So you can literally write them all out, too. That's 120. How could I represent this one if I wanted to with the P? Does multiplying by 1 do anything? No. What's this one starting at? It's going down by 1 each. Starts at 6. P, how many does it go down? 3. That'll be 120 as well. You try C. First and last letters must be vowels. Now vowels are what? I didn't realize people don't know all the vowels. A, E, I, O, U. There's no sometimes Y in math. Because sometimes Y comes in when a word doesn't actually have a vowel, right? Which we're not dealing with. So Y start with consonants. So there are 5 vowels and 21 consonants in the alphabet. Because the alphabet has 26 letters. So there's 5 vowels. In English, though, do we have 5 vowels? How many vowels are in English? 2. We agree? So we have to start with the restrictions first, which is the first and last must be vowels. So what options do I have for the first then? E or I. So how many options do I have? What do I always have to do when it's a word? Box and hold. So I'm going to hold the I. What do I have for this one now? Yeah, just the E. So now I've used up the E and the I. True statement? What do I have left? Yeah, I have N, G, L, S, H. 5. So I hold the H, then I would have 4. You type it in, you should be in 40. The word must contain a G. Does it say where the G has to be? How many options do we have where the G could be? We have 4, right? It could be in the first, it could be in the second, it could be in the third, it could be in the fourth. So you could show all 4 cases. You could go put it in the first, or put it in the second, or put it in the third, or in the fourth spot. And every single case you start with all the letters in English again, right? I always have to start with the restriction first. So I'm going to start in this first blank here, which is 1. Then how many letters do I have left for this blank? How many? Use up the G. How many do I have for this one? How many letters are in English? I know you know this answer because you can literally add them up. Izzy, how many letters are in English? Yeah, 7. How many are left? Thank you. You could have just answered that without me forcing you. Friends. What have we got here? Yeah, then? You're acting like I'm like butchering through it. You know these answers. I know you do. So what about this one? Okay, Matisse, she's forcing me to move upward. And the G I have?
6.
No, this one I have 1. Used it up then. Use your answer again.
6.
Yep.
5.
Yep.
4.
Yeah. Do they give me a different answer? 6 times 5 times 4 or 6 times 1 times 5 times 4? They're all the same answer, right? This is 120. This is 120. This is going to be 120. This is going to be 120. So instead of showing every case, we talked about this at the beginning. How many places could G be? 4. And what does one case get me? 120, right? So instead of going 120 plus 120 plus 120 plus 120, what should I have done? 120 times what? Right. Then we're flipping over. Your turn. Guess what your turn means? Your turn. And then there's a diploma practice question. And another one. And another one. And another one. So you're going up to number 4. So this page and up to 4 on the next page. Try them out. This one says a luggage lock opens with the correct 3-digit code. Can we not start with a 0 if it's a code? Codes are fine to start with zeros, right? The only thing you can't start with a 0 with is a 3-digit number. Codes can start with zeros, they could all be zeros. Each wheel rotates through the digits 0 to 9. How many different 3-digit codes are possible? No, nothing said about can't repeat, right? So we assume we can. The only time we can't repeat is if we're literally not allowed to because it says we can't, or they give us, here's the word English. So that's all you can use, right? English words are not repetitive. You have what you have. So here I would have 0 to 9, 0 to 9, 0 to 9, which is 10 times 10 times 10. Make sure you have these dots or it's not 10 times 10 times 10. It would be 101,010. So this is 1,000. Make sure you put those multiplication dots. The next one says, suppose each digit can be used only once in a code. So once again, can't repeat. How many different codes are possible when repetition is not allowed? So we start with our first one, 0 to 9, which is 10 options. Box and hold, because it can't repeat. 0 to 8, which is 9 options. And then 0 to 7, which is 8 options. And you get 720. Because you can't repeat. So you box and hold. The next one says, an Alberta license plate has 3 letters, followed by 3 digits. And we multiply, we don't add, because we need all of them. We need this, and this, and this, and this, and this, and this. It says here, the letters I and O are not to be used to avoid confusion with the digits 1 and 0. So 1 and 0 is fine, but I and O are pulled. So for the letters, I only have 24 options for the first 3. It doesn't say I can't repeat, correct? So I can. And then digits, I have 10, 10, 10. Because it's the digits 0 to 9. So it's 13,824,000. Because of the growing number of vehicles, the province is changing the plates with 3 letters followed by 4 digits, which is what they've done, right? They were scared they were going to run out of things. So they added an extra digit. Adding an extra digit adds an extra multiplication of 10, correct? So it actually moves it to a whole new placeholder. So instead of 13 million license plates, just by adding an extra digit, they're going to have 130 million. Like, it just hugely moves it. If they had left it be a letter instead, it would be 24 times bigger than 13 million. It would be even bigger. So you get the same thing, 24, 24, 24, 10, 10, 10, 10, which just adds an extra 0 to your last example. 138,240,000. Now remember, you guys, you can read these numbers really easily. People get overwhelmed by big numbers, but really what you're doing is you're reading a 3-digit number and putting the word millions or thousands behind it. So this is the number 138, correct? It's in the what spot? Millions. This is the number what? 240, correct? And it's just in the thousands. So this is 138,240,000. That's all it is. This is 13. It's in the what? Millions. This is 824. It's in the thousands. And then I have nothing. So it's 13,824,000. That's all these numbers are. For some reason, when you're little, they get explained like they're really hard or something. But as long as you can read a 3-digit number and know what place it's in, you can read huge numbers. Okay, this one here. Sally wants to decorate one wall in her room with movie posters. She'll hang 5 of the 8 posters across her wall. So it's a permutation. Oops. It's a permutation because she's literally arranging them. Arranging means it's giving it order. So it's a permutation. Sally places her favorite poster in the middle. Then the number of different poster arrangements are possible. So I drew my posters over here. So here are my 8 posters. It's really beautiful. Can't do them on the whiteboard or on the smartboard anymore because it acknowledges them. So I put my favorite poster in the middle. How many options do I have for it? It's one. It's literally called favorite. That's how it's my favorite, not because it's the best. So now in this blank, how many options do I have? I have 7. Now people will go 7, 7, 7, 7. Are you ever leaving a poster behind if you're doing 7, 7, 7, 7? Nope. You're like, okay, I'm going to put this poster here, and then you're like, sorry. You just pull it right back off. And you're like, I'm going to put this poster here. Sorry. You pull it back off. You're never, ever leaving posters behind. That is what you're doing. Right? So I leave this poster here. I had 7 options. Then I leave this poster here, 6 options. And this poster here, 5 options. And this poster here, 4 options. I still have 3 just sitting through that I'm never putting on a wall. Right? So I have my favorite poster in the middle. I have 1 option here. Then I have 7 poster options here, and I leave 1. Like poster number 1, let's say I leave here. Then I have 6 options, and I leave poster number 2 here. Then I have 5 options, and I leave poster 3. And then I have 4 options, I leave poster 4. And then poster 5, poster 6, poster 7 are still just rolling around and not on the wall. And poster favorite is there, right? 7 times 6 times 5 times 4 is 840? No. Yeah. Yeah, because it'd be 420 times 2. Okay. This one. In 1951 to 1981, the first digit of every 3-digit telephone code in North America was the number from 2 to 9 inclusive. It was 2 to 9 inclusive, and that was first digit. Then we have the second digit was 0 or 1, and the last digit depended on the following rules. If the second digit was 0, then the last digit was 1 to 9. If the second digit was 1, then the last digit was 2 to 9. Digits could be used more than once. The number of different telephone area codes that could be formed with these restrictions. So I have 2 cases, correct? I have one case where the first one is 2 to 9, and then my middle one is 0. And if it's 0, then this one is 1 to 9. Or, which means the plus sign, I have 2 to 9. My middle digit is a 1. And then my second digit would be 2 to 9. Correct? So 2 to 9 is 2, 3, 4, 5, 6, 7, 8, 9. 8 numbers. Use your fingers if you have to. It's better to use your fingers and get 8 than not use your fingers and get 7. That looks more dumb. I would rather you count. I use my hands all the time. So this is 8. This is 1. This is 9. So that's 72. Plus 8. 1. 8, which is 64. And so I get 138. 6. Wow. I multiplied 2 and 4 for some unknown reason. 136. Now we're going to flip over. Okay. This one says, how many distinct 4-letter arrangements, so I know I have 4-letter arrangements, so I have 4 blanks. We're using script. Script is 6 letters. Can I repeat script? Can I repeat the S, the C, the... No, I have 1 S, 1 C, 1 R, 1 I, 1 P, 1 T. So I have S, C, R, I, P, T, 6 letters, hold 1. Box and hold, because I have to when it's a word. S, C, R, I, P, 5. S, C, R, I, 4. Then S, C, R, 3. And I get 6, 5, 4, 3. I can go 6, P, 4. Is it 720? 360? I'm just randomly guessing numbers. It's not 24 or 15. I had a 2 out of 2, 1 out of 2 chance. Guess not. I don't even know where 24 comes from or 15. Those are terrible answers. Even if you add them up, it doesn't get you that. Someone might have got it. Anyone good? Those are tiny. Okay, we have how many 5-digit odd numbers are there without repetition? 5 digits. 1, 2, 3, 4, 5. It has to be a 5-digit, so I know I can't start with a 0, and it's an odd number, so I know I have to end in 1, 3, 5, 7, or 9. It also says without repetition, so I have to box and hold. We agree? So I have 5 options for the back. Say I box and hold the 9. Then I have 1 to 9 here, which is 10 option. Nope, which is 9 options. Sorry. Hold the 9. Then do I have 1 to 8? I've already held the 9. Oh my gosh. Let's go back. Try again. This didn't happen, except it's on a podcast, so it did. Okay, so I have 1 to 8, sorry, which is 8 options. Hold the 8. Then I have 1 to 7. Or what do I have for the second blank? 0 to 7. I have to remember to bring that 0 back, because I couldn't use it in the first blank because it wouldn't be a 5-digit number. Can't use it at the back or it'd be an even, right? So this is 0 to 8 to 7, sorry. which is 8 options, hold the 7, 0 to 6, which is 7 options, hold the 6, 0 to 5, which is 6 options. And what do we get? 440? Okay. You guys are going to work on the homework questions. This first one, I'm going to draw your attention to a couple. This one here is, you're going to arrange 6 different math textbooks. Yeah. Yeah. When you arrange 6 different math textbooks, people will put 6 lines and then they'll go 6, 6, 6, 6, 6, 6. Are you ever leaving a math textbook behind? No, you're going, okay, I'm going to have 6 options. I'm going to put this one here. And then I'm like, nah, and take them all back. Then I'm going to have 6 options for this one. I'm going to take them all back too. Then 6, I'm going to take them all back. Am I ever leaving a textbook behind? No, I have 6. I have 6. I have 6 textbooks. I leave 1 behind, then I have 5 for the next blank, right? Then I leave 1 behind and I have 4. So you have to take down a textbook each time because you're leaving 1 behind. The other one I want to draw your attention to is this one. It says, with the new renovations completed at Holy Trinity Academy, there will be 7 entrances. In how many different ways can a student come in for math tutorials if they enter and exit through any entrance? How many blanks are you going to have? 2, thank you. So many people put 7. You're not going to have 7 blanks. You're going to have an enter blank, and you're going to have a exit blank, and you have to tell me how many options you have for the enter blank and the exit blank. Okay, 2 blanks. And then one more I want to draw your attention to. Oopsies. Okay, this one here. I put a little memo in it already. Okay, you can try these all out. These are your homework. And then I'll put the answers to the homework, not worked out solutions, but I'll put the actual answers on this board. Okay, so try them out.